going to share something. Are we able to see what I'm sharing?
Yes, we can.
All right, so in today's session, we will introduce you. Good afternoon, everybody. Sorry. In today's session, we want to introduce you to how we are going to access our data sets that we talked about, introduced yesterday. And so we will take you through how we are going to download GLDAS dataset, the GRACE dataset, MODIS evapotranspiration, and the precipitation dataset. And before we start this exercise, we all must be registered first to Earth Data website, and I hope everybody is now registered. I can't hear any response actually. And then we also expect that by now you have your QGIS installed. And we also have the basin shapefile that we sent to you. And the link for those that have not yet downloaded, we also sent to you the link and the shapefile itself. So may I allow Frank to start with introduction of how we are going to download our precipitation data sets? I'll pick it later.
Okay, thank you, Dr. Subila. Let me share my screen first. Okay, so welcome all to today's session, and we will be more focusing on how we can access and download this observation data and GLDAS data. So our today's session will be in form of demonstration on our side, and you all will follow the similar steps so that at the end of this session, we will be having the data already downloaded and saved to our computers already for analysis, which is for tomorrow's session. So I'll be demonstrating on how you can access and download this observation data. And Dr. Subila will take over on how to access and download GLDAS data. So we will cover the following. We'll download data from GLDAS version 2.1. Then we'll download data for GRACE mission, which is the waste water storage. We'll download data for evapotranspiration for MODIS mission. And we'll finalize with precipitation data from IMAG. And as earlier said, you must have registered this data account. But if you have not done so, we will demonstrate here, but you have to register maybe right now. It is simple. So you must have QGIS installed as a prerequisite of this exercise. And we will register also NASA data account. And here you can access Limpopo River Basin shapefile. We will be using this shapefile for downloading a subset of remote sensing data. So basically, we will start by downloading IMAG precipitation data, and we will download precipitation data for the following months. We will stick on 2 seasons, which is wet season and dry season. So for wet season, we will download data from December 2019 up to March 2020. And for dry season, we will download data from June to September 2020. But a quick introduction, what is IMAG? IMAG is integrated multi-satellite retrieval for GPM satellite, and basically IMAG combines information from GPM satellite to estimate precipitation over the majority of Earth's surface. So basically, this image data is valuable over the majority of the surface that lacks precipitation measuring instrument on the ground. So basically, all the latest images of image data were fused with early precipitation estimates that was collected during operation of TRMM satellite that ceased its operation on 2015. And the precipitation estimates collected during the operation of TPM were fused together by precipitation estimate from TRMM satellites to produce image dataset. And this dataset is the open source. So basically, this is the first step on how to download image precipitation. So we'll go to this link. I'll copy this link and paste to the chat box so you can follow also. So I will open this link.
And Frank, just a minute. Can we, Dr. Kujinga, can we have all participants also following the steps also by themselves and downloading this data set at the same time that he is also doing so?
Okay, that's okay. So all participants can go to that site and follow the instructions that's being given.
Okay, so everyone can open the link I just sent to chat. You must appear to this landing page, the Giovanni website. This is the site where we can download image dataset. So basically, by introduction, Giovanni allows to visualize selected geophysical parameters. So to download data from the Giovanni platform, you must register with S-Data account. Or if you have already registered, you have to log in here. So I will hold for 30 seconds to allow everybody to reach at this landing page, and then I will demonstrate how to log in. So after you have opened this link, just click login. It will request a username and the password for you to log in. So if you have already registered, just input this information. But if you are new, just open register. So you will fill all of the required information for you to have an authorized account where you can download all this information. So I have an S-Data account, so I just write my username over here and my password, and just click login to continue. So as you can see, I have successful logged in. You can ask any question if you face any bug or any error, so that I can solve it immediately. Is there anybody I was successfully here at this page?
I'm there myself.
Okay.
I'm there as well.
Okay, so we proceed on the next step on how we can get this data. So under this tab, under select plot, just click on the drop down and select map accumulated. So basically this option can give you data that is accumulated over a certain time period. So just select map accumulated, and under the select date range, you have to select the date range specifically according to what kind of data you want. So for our case, as we said, we will download data for wet season from December 2019 up to March 2020. So we'll start to download data for wet season independent, and then we'll go for dry season. So just select your date here. So this is a column where you can input your year of start. Then it is 2019 for our case. For what season is December 2019. Input month, which is December 1st. Then we download data up to 20 of March 30th. So just input your date range, and under select region, there's two options. You can choose bounding box coordinate. This is where you have to input your shapefile, which is the Limpopo River Basin shapefile. So there's two options. You can either put bounding box coordinate, that is the coordinates for Limpopo River Basin, or you can just click on this icon, and you'll be able to search for Limpopo River shade, Limpopo watershed. I mean, you will search its shapefile online. So we will use this option to search for Limpopo watershed online. So just type Limpopo, and you will see it is here. Just click, and it have to appear on our map interface, as you see this green street, and then you can cancel it. So the next step is we have to search for the specific data we want. For this case, we want to download the image interpretation data. So on this search bar, just search image. You see some outputs. So select image final and click search. So the following results will appear. So basically, we will be downloading this output, which is made the satellite dodgy precipitation estimate final line recommended for general use. As you can see, it is a GPM data. So be sure to select the second option. And on the unit parameter, we will be converting all this data to millimeter per month. So just select this drop down and select millimeter per month. Here is the source, as you can see. It is a GPM, it is derived from GPM satellite, and its temporal resolution is monthly coverage. Here is the spatial resolution, 0.1 degree, and this is the beginning date of this mission and end date. But basically, GPM satellite was initiated in 2017. But as I said earlier, this data have been fused with TRMM data, which failed in year 2015. So basically, that fusion has resulted to this beginning date up to this end date. So just select the second data and set all options, and then click here, go to results. So this is the output. We'll be able to see the following output. Are we together up to this point?
Can we check on other participants?
If there are any challenges, please kindly say so.
I think on the chat box, we have somebody saying, I don't have the view option.
Okay. You have to click go to results. It is in a button corner, light button corner. Okay, I'll go back.
Yeah, I don't have the option. The button doesn't appear. I can see plot data. Is that the one?
Yes, it is plot data.
Okay.
Okay.
It's doing something now. Yes.
It is good now.
Yes, thank you.
Okay. I will wait for 30 seconds maybe for all to reach at this web page. Okay, so to proceed, just navigate on this download option and click on this drop down and select GeoTIFF. We'll be dealing with GeoTIFF file extensions because it is easier to process this kind of data. So just click GeoTIFF.
Okay, as you're waiting, Frank, somebody is asking why his values are different from yours. I think they didn't change the units.
Yes, it is important to change the unit.
Yeah, somebody skipped that step.
All right. Can I get a view of anyone if they are able to download? I receive internal server error. Is everybody receiving this window?
No, we're able to download anyway, but I think maybe it's just your internet. Maybe you don't know.
Okay, so I will continue. So the moment you click download and select GeoTIFF, it have to give you an option to save your file. So just save your file with a short name and you are good to go.
Hello? Frank, for
Yes.
me, yeah, for me, a pop-up window is appearing with the downloads. So there are a number of file options which are appearing. Is that what you are referring to?
Yes. You have to download
All of them.
Of course.
Okay, so, okay, let me download all of them.
Let me check first why it's loan this error. I'm trying to change my browser. Maybe it's a problem of browser I'm using.
I think, Frank, you're getting there.
Yes.
All right. For those that are asking about units, on that window that that before you clicked plot data,
It is here,
there
this window. Make sure you change this unit to millimeter per month.
exactly.
Sorry. Hello.
Yes.
Yes. In my case, doesn't in my case when I do this doesn't come a button of the result.
Can you repeat?
When I try to find the data,
Yes.
I make the two procedure, but the button of result doesn't come in my screen.
I didn't hear him well. We couldn't hear you well. What exactly is your question?
Yes, I was see what they doing it now. I try to do again, but in my screen, when I want to go to the result, the button result doesn't come in my screen. Doesn't have in my screen.
I didn't hear well. Can you type your question, please?
Can you put it in the chat?
Okay.
All right. So for my case, it was a problem of browser. I think Firefox is not supporting. So you all must reach this result. This is the final result you have to reach. The precipitation data for December 2019 up to March 2020. So just click download then GeoTIFF. It will start downloading over here. As you can see, I've already downloaded it.
Can you show us again, Frank? Sorry.
Okay, I will start afresh. On how, okay, let me start afresh. Okay, the first step you have to log into your estate account. Then under select plot, make sure you selected map accumulated, and then we will download data for wet season for now. So just select data from December 2019 up to March 2020. So make sure you input that date under this field, which is 2019 for December, and then input here 2020 for March, and then select your study area. For our case, it's Limpopo watershed. So I select watershed for Limpopo here. Then be sure it visualized on this map. And then I will search image, then select image final. This is the data we need. And then click search. We will use the second option, which is the matched satellite dot precipitation estimate. And make sure you change the unit. We will be using millimeter per month. Click this drop down and click millimeter per month, and then click plot data. So it is processing now. And here is the output. So to download it, just click on this drop down and then select GeoTIFF. And here, as you can see, it has downloaded. I hope I'm clear now. Are we clear? Can we continue?
Frank, I think we can move a little bit.
Yeah.
So that.
Yes, let's continue.
Okay, so I will demonstrate also how we can download for dry season. We have downloaded it for wet season. So just click on back to data selection. And then you have to change the timeline. So for the case of dry season, we download data from June 2020 to September 2020. So just change this year, and then input for June, and then up to September 2020. It is here. So just make sure you leave all other settings as default and just click plot data. So here is the output. So just click download and select GeoTIFF, and you are clear to go. It will start downloading. So I will go next, and our slide says we have to download evapotranspiration data from MODIS. This is a manual. I'll give it to you. It highlights all the steps. So next, we will be required to download evapotranspiration data from MODIS. So basically, we will use the same timeline from December 2019 up to March 2020 for wet season. And for dry season, we will download data from June up to September 2020. But things to note, the start and end dates are in Julian days. And basically, Julian days are a number of days since the beginning of the year. This is an example of Julian days. So the first day of the year is counted as 001, and the last day of the year is counted as 365. So this is an important table to understand.
Okay, just a minute, Frank. That is it just me that your screen is stuck?
It's that.
Because we're
No,
still seeing the Giovanni. Oh, it's just me. All right, now it has moved. Okay, great.
It's okay now. Okay, so I will repeat a bit. We will now be downloading MODIS evapotranspiration data, and we will stick with the same timeline for wet season and dry season. But basically, the point to note here is MODIS evapotranspiration data are in Julian days. Each data in Julian days, and basically Julian days are the number of days since the beginning of the year, and this is an example of Julian date calendar. So basically, the first day of the year is counted as 001, and the last day is counted as 365. So basically, it is important to have this Julian date calendar to be able to download data from the evapotranspiration data from MODIS. So this is a file name with its product description, as you can see. And this is a mod 16A2. By description, MODIS have both sensors for Taylor and Aqua. So this short name is basically for Taylor product from MODIS. So basically, we will be using a Taylor product. So I'll go direct and demonstrate how we can download data from MODIS. So here is a link I will share also in the chat box. And I'll just copy and open it on another browser because my Firefox is not working well. I hope you see my screen well. I hope all you see this screen for API's website.
Yes.
Okay, so this is a web page for downloading MODIS evapotranspiration data. And basically, APIs is an application for extracting and exploring analysis-led samples that can offer a simple and efficient way to access and transform geospatial data from a variety of archives. So basically, archives enable users to subset geospatial data set using spatial, temporal, and band parameters. And basically, there's two options to extract the data from APIs, that is point sample and area sample. So basically, our study area is in Poco River Basin, which is a vector file. So we must extract the data in form of area sample. So just make sure you sign in with the same data account. And then navigate to extract option, and then select area sample. So this is a new rendering page. So next, you have to start a new request because it is a new request. But if you have been using this platform, you will find all your records over here. So I'll just start a new request. So just click on start a new request. Are we together up to now?
Yes, we are together.
Okay, under the enter name to identify your sample, we will start by downloading data for wet season. So you can enter a description to identify your sample because they will be sending a link, download the link to your email. So just make sure you input your product name. So I will rename as evapotranspiration, and this data is from December 2019, maybe up to March 2020. So just make sure you enter upload that name, and we have to upload or draw a polygon. This is the shape file. We want to upload this file so that we can subset the data. Modis has a global coverage, so we have to upload our shape file, which will be our study area, so that we can use to subset the globally spatially data. So just click on this link here, and it will ask you to browse Limpopo River Basin data. So I hope you have already downloaded the Limpopo River Basin share file. So just navigate to where you saved it, and be sure to select only this zip file. It must be in zip extension. So select it and open. You have to see an output on this map, demarcated Limpopo watershed. Then there's the option for temporal resolutions. So for our case, for this case, we download data for wet season from December 2019 up to March 2020. So you can input your start date, which is December 2019, and an end date, which is March 2020. And the form is you have to start with the month, then days and year. So it is December 1st, 2019, up to March 30th, 2020. After doing so, just scroll down, and under select the layer to include in this sample, just click on this bar and type MOD 16. You have to get these three outputs. So as I said earlier, we will use TerraModis. So you have to select the second option, which is TerraModis net evapotranspiration gap field, and it has a spatial resolution of 500 meters, and it has a temporal resolution of 8 days. So just select this option, and it will result as output. So basically, this product has a data for evapotranspiration, and this is a quality assurance data for evapotranspiration. This is a latent heat flux. There is potential evapotranspiration, and there is potential latent heat flux. So basically, we will need evapotranspiration data. So just add this evapotranspiration 5 meters, and it will appear on this box under selected layer. So scroll down. On the output box, we have to select our output file format. So we will use GeoTIFF. Just select GeoTIFF. And under the projection, just select geographic projection. And the output will be like this. Data have to be WGS84. And projection, specifically CLIS coordinated defense system, has to be EPSD 4326. Then scroll down and submit. You will receive this message that the area sample request was successfully submitted. An email notification will be delivered once the request is complete. So in just a matter of 30 seconds, you will receive a downloading link to your email. The same email you use to register with a state account, just navigate to your email so that you can download it. I hope you see a window with my email inbox. So as you can see, I just received an email. It is here from Appeal, saying that my request was received. So they are processing the data. So I will be receiving second email with an embedded data link. Is anybody already received an email for a download link? Is anybody received the download link?
Yes, I see Bright has received the link.
Okay.
And there is someone who is saying he's lost.
All right. Let me go back. So we are here. The main option to fill in is just enter a name to identify your sample. So we just input our product name. Then make sure you click to upload your shapefile. Just upload the Limpopo River Basin shapefile, which is in a zip format. Select and just open it, and its output will appear on this map. And then select the start date and end date. And for this case, we are downloading data for wet season, which is from December 2019 to March 2020. So just input your date here, which is start date, and input your end date. Then scroll down. Okay, let me demonstrate again. Just search MOD 16 on this bar for search for product, and then select the second option, which is Terra Modis, native evapotranspiration, gap fill. So just select this option.
You are too fast, Frank. A little bit.
Okay, sorry.
Yeah, so let's check if they got it up to that point.
Okay, I think this is the layer you have to select, Terra Modis. net evapotranspiration depth field. And then you have to select each a 5 meter. We are downloading evapotranspiration data. So under the result of thermodynamic net evapotranspiration, just add each 5 meter on a selected layer. It has to appear under the selected layer box. And then select your file format to GeoTIFF. And then on the projection, make sure you select geographic. And then click submit and go check your email. You have to receive a download link. So basically, this is the email I was talking about. It says that my request was completed successfully. So you'll find all information on this email, so request details, documentation, citation, and etc. So here is the download link. So just open this download link. I have to open to my another browser. It is not requesting for login, but it is just redirecting it. Yeah. So here is your file. Just scroll down and make sure you select all. You have to download all. There are almost 34 files, and basically they are many number only because Modis data have a spatial resolution of 8 days. So in a month, you must have almost four data present in a month. So just select all, and then under this drop down on download, just click download file. You will see downloading progress, and you will see your file are downloading. It will ask you to choose your directory where you can save it. So just choose. So I will cancel because I have already downloaded it, but you have to wait until they are all finished. There must be 34 files. Are we together? All right, so these are the process of downloading Modis evapotranspiration data. So we have just downloaded data for wet season. So the steps is similar. So after the downloading is complete, just navigate back to the same web page, and only attributes you are required to change is just change the product name. So for now, we'll be downloading data for dry season. So just change the product name to evapotranspiration. which is from June 2020 up to September 2020. And then you have to change on your temporal resolution. So make sure you input a start date from June 2020 to September 2020. Then leave all other settings as default and just click submit, and you will be receiving a downloading link for evapotranspiration data for dry season. Just open that link and it will start downloading data for dry season, but it is recommended to choose your working directory. You have to save all your files independently. So make sure all the downloaded files for wet season, it is saved in independent folder, and the data for dry season also saved the independent. Just is an analysis for tomorrow's session. I think we can proceed to download other data. So for dry season, you can download even at your own time, but the step is just similar. Just change the date option and product description option. Click submit, you receive a download link to download all your data. So next, we have to download data for terrestrial water storage. And this data is from GLACE mission. I hope you see my screen. It is a download GLACE for terrestrial water storage data. You see that screen?
I can see it. I'm not sure about others. So
okay. So we'll go again to download data for terrestrial water storage. But basically, for this case, we'll download data for wet season range from December 2019 up to April 2020. And for dry season, we download data from June up to October 2020. And basically, this timeline for terrestrial water storage is different from other data sets because on the analysis part on water budget estimation, we'll be finding a terrestrial water storage change, which will be required to find the difference of terrestrial water storage in every month. So to get the terrestrial water storage change for March, we have to minus data for April from March to get terrestrial water storage for March, and then for dry season to get terrestrial water storage for September, we have to minus terrestrial water storage data for October minus September to get terrestrial water storage for September. So basically, to download GLACE 4 mission, it is very simple, but just by description, GLACE 4 mission is a gravity recovery and climate experiment mission. And specifically, there are two types of this mission. There is GLACE mission and GLACE 4, which is we are going to download its data. So GLACE 4 mission, which is GLACE 4, is a mission which is a successor to the original GLACE mission, which orbited from 2002 and ceased its operation to 2017. And then GLACE 4 was launched to dramatically improve the already remarkable precision of GLACE mission. So basically, GLACE 4 mission launched on 2018 to monitor Earth's water movement. So to access this data, there is a link. I will share with you this link. So just click that link and you will land to a repository. It is a cloud storage where you can find all the GLACE 4 terrestrial water storage data. it is stored on the cloud. So I'll open that link. It also requires data account to download, but if you have already registered and logged in, just click continue to data login and it will redirect automatically. So here is a cloud repository where you can download all terrestrial water storage data from the GLACE mission. And basically, as I said earlier, we download data from December 2020 up to April 2020 for wet season. And data for dry season, we download from June up to October 2020. So basically, to download data for GLACE mission, you have to understand Julian dates. So it is important to understand Julian dates. So I will show you the Julian date calendar. Here is the Julian date calendar. As I said, we have to download data for December 2019 up to April 2020 for wet season. So we will see a Julian date for December. Is here December, as you can see. A Julian date for December is 335 up to 365. So you have to find this date on the data set. Yes, this is a cloud repository. So just find that Julian date for 2019, which is for December, is 335 up to 365. So just scroll down and find that Julian date for 2019. As you can see, here it is. It is GRD3 2019, and Julian date is 335 up to 2019. A Julian date is 365. So basically, this is a data for December 2019, and we will download GeoTIFF file just to maintain consistency with other data types. But basically, on this cloud storage, there are a total of 3 file extension where you can download. There is GeoTIFF file extension, there is MD5, there is NC command, there is text files, but we download a GeoTIFF. So I will just download in the terrestrial water storage for December 2019, which is here. As you can see, it is 2019 with the Julian date for December. So I will just click this, and as you can see, it is downloaded. So to download data for terrestrial water storage, it is important to understand which Julian date for specific month is. And to understand Julian dates, just you can search online Julian date calendar. This is the Julian date calendar. So if you want to download data for January 2020, just navigate to January, and this is the start date for January in Julian date, which is 001 up to 061. So just on the GLACE 4 repository, just find the data for January. Make sure it is 2020. As you can see, this is the data for 2019. So scroll down to access data for 2020. As you can see, it is here. It is 2020 with the Julian date 001 up to 2020 031. So this is basically January 2020. So make sure you choose the TIFF file. It is here, January 2020. Just click this TIFF file and it will start downloading. So I left to you as an exercise. You will be downloading the terrestrial water storage for remaining months, and make sure you save your file to a specific working directory, because we will be dealing with analysis tomorrow. And make sure you can rename all this file whatever you want. I hope we are clear now. So I will end up here. Just in summary, we have just downloaded terrestrial water storage data, evapotranspiration data from MODIS, and the precipitation data from IMAGE. So all of this data are open source and from remote sensing observation, but others are not directly observed by satellite, are just produced by special algorithms. And so, yeah, thank you. For now, I'll leave to Dr. Subira so that she can proceed to demonstrate on how to download data using GLDAS. Over to you, Dr. Subira.
Okay. I hope we are fine up to that point. If we are okay, so that you're able now to proceed. Can we go to the next data set, or do we have problems at that point first? Any queries? Somebody is asking for a break for 5 minutes, maybe to just give them. Others we can continue. So, Dr. Kujinga, what should we direct us?
It's up to you, Doc. Maybe people want to stretch a bit, go to the washroom, maybe. Yeah, just give them a short break, yes, and then we can continue.
Thank you, Doctor. So let's have a 5 minutes break then. Thank you.
Okay.
All right, so let me share my screen. All right, so are you able to see my screen? We start. Okay, so now we have gone through the gray satellite, MODIS, evapotranspiration, and the precipitation data sets. Now we want to be able now to go to GLDAS data sets that we say they're going to give us the water budget components. And I introduced this global land data assimilation system yesterday. It's actually the data that is provided by NASA, and it's freely available. It's actually hydrological specific kind of data sets. It's quite easy. I like to use it. And it's actually a bigger mission for them. But for us, we are probably just interested in the hydrological data sets. And for today, the water balance component is part of it, but it's a large database that they have there. It's a global database. And they have 3 hourly data sets and monthly data sets. And you'll see that on the list of the databases that the data sets that they have the CLM, Mosaic, NOAA, they have all these kind of land surface models that they've used to generate these data sets. And they have 1 degree data products that cover 1979 up to now, and 0.25 data sets. And as I said, it's a large database. Actually, they have a lot of information there. And for today, we will only look at probably total evaporation, precipitation, and surface runoff, just the water balance components that we are interested in. But there's much more in that, in the GLDAS data set. So today we will download precipitation, evapotranspiration, runoff, and total water storage. for the wet season and for our Limpopo Basin. Our wet season actually covers December, January, February, and March. And we have dry season June, July, August, and September. So I want us to, I've shared this link already. So I want us to go to the link. You can check on the chat. Let me now also navigate. Okay. So that is the link. I hope everybody could get to this link. I don't know, are we together really? All right, so we can start since I cannot hear anything. I'm not sure what is the response. So I want us to, we are looking for GL data set. So we are looking for monthly data sets. There are a lot of, as I said, GL data sets, and we are looking for monthly data sets for our Limpopo Basin. So we have monthly data sets 2.0 and 2.1. 2.1 is more compact and more recent, so we'll click that. Now, I hope everybody has reached that point. Are you able to see my window explorer?
Yes, Doc.
All right, so after you type in the data set that you want, you can click search. I hope we are going together up to that point. Now you have your data sets here. And we have a place where we can subset our data sets. We can click on the data set to understand it very well. This is a 1 month resolution. The spatial resolution is 1 degree, okay? And we have the beginning and the end date. So the data set actually runs up to 2021 now, September. So I'm clicking on the data set to understand it better. So this is a monthly 1 degree data set. Okay. And the information of the product summary is here. The original files are actually stored in .NET-CDF formats, but that doesn't limit us. We can still download them as GeoTIFF. And the data citation is actually here for if you want to understand more, there are publications on that. And more documentation on those things and references that are out there. So we want to be able to use this data set. So we'll quickly go to data access and subset our, or get our data. Because this is a global data set, we want to only get the Limpopo part, and we know the months that we're interested in. So would we please go to subset? I hope everybody is seeing the window that I'm seeing. After you go to subset, you are able to subset. Now you have to choose the method that you want to use for downloading. And for this exercise, let's use get the file subset. And we will now refine our search to the date that we are interested in. Are we together to that point? I don't know. Silence means something. Okay, so I'll continue. This is 2019. From 2019. December 1st. Up to 20, this is 2019, up to 2020. End of dry season. Let me just, that doesn't exist, okay. So I've subsetted it, I've selected the dates, the data range that I want to now download my GL data sets. Now the region, so that I don't, download the whole global data set, we want to refine the region of interests. And so because we are talking of Limpopo, so it's actually 25. Okay, because I've done it before. So I've refined it to this area. Okay, so Limpopo is around that. So I've refined the region as well. Okay. Now next, we want to be able to go to our variables. As I said, we have a number of them. There are actually a lot. So after you expand the variable drop down, go to evapotranspiration data sets. So let's look for them.
Sorry, can we get that extent again? Otherwise, we're going to fall behind.
Okay. Where do I start? We start afresh.
I just need to get that bounding box.
Oh, okay. Just need to get that. You have the dates already here? Yes,
so it's one, we just download the whole thing, it seems like. Dry and wet. Okay, so it's 25.
Yeah. We'll get the whole time series because it will come as monthly data sets. These are monthly data sets. So we want to get all the months that you're interested in, and then we'll download one month after the other. You understand? Okay, so now we have the bounding box. As I said, because this is Limpopo Basin, this is Limpopo River Basin. So can you please key in these values, the latitudes and the longitudes, so that we narrow down our search to this. So is everybody at that point?
Yes, I've got it. Thanks.
So after that, can we go to the variables now? As I said, we have many variables. I want us to start with the evapotranspiration, total evapotranspiration first. And so, well, because as I said, we are interested in our outer budget. So there are a few things that we're interested in. We are not interested in all the data sets that are here at this moment. So I'll just click that. All right. So now under our output format, we now decide the original, as I said, they normally come as net CDF, but we can download them as GeoTIFF. This is more friendly for most, softwares that we normally use. So we want to download them as GeoTIFF. If we are already there, we can now click on the Get Data.
Sorry, kindly please go again on the data sets.
All right. Okay, let me go back. We start here or we start further back? We start at subsetting of.
No, on the variables.
On the variable, okay. On the variables, we say that we're interested in a water budget for Limpopo, and we will now just start with evapotranspiration first. So we just select, it was not selected, we just selected evapotranspiration. We'll download one variable after the other.
Okay,
Later we'll come to surface runoff, but now we're just going for evapotranspiration first only. I hope we are fine.
Yes, we can proceed. Thank you.
All right, thank you. So now, as I said, you also need to select your file format. Can we select GeoTIFF? Now, with this interface that we are using, when we select GeoTIFF, it means that we are downloading one data at a time. Only you'll see we will not be able to download all of them, like all the months that we're interested in. We'll have to download 1 month at a time. Okay, so we go for get data. After some time, you'll get this window. I hope we are getting our window.
Hello, I'm sorry.
Yes.
Hello?
Hello?
I'm sorry, can you please help me to get the binding coordinates for the region?
All right. Let me also go back.
Okay.
Maybe you're not the only one. Yeah, so let's go back. We want to refine our region and select only what we're interested in.
25.
And so we have, yes.
25. Okay, negative 27. 35.0. Okay, thank you very much.
Thank you. So any other issue, or we can proceed? Okay. We can proceed to get data after. I hope you selected GeoTIFF already. The file format. So we move. So now we have our monthly data sets. This is 2019 December. Then we have 2020 January, February, March, up to, because we said we wanted up to September. So we have our monthly data sets. We have instructions also for downloading, how you want to download it. If you want to create maybe a URL and then go there and download each one of them. But the simplest way for now, let's just click. Okay, I have a little bit of a warning on my system, but it's okay. So you can click and download one file after the other, one file after the other. So I will just say maybe this is December. This is my 18 December 2019 and save it, wherever. And so it will start downloading and you save it. So you just click, when you click it, it will take it to where you can save it. So January 2020. Like that. So now we are at a point where we can download all the monthly data files, and these are for just evapotranspiration only.
Hello?
Hello?
There is no way of downloading all these data sets at once as a zipped file.
Can you see instructions for downloading here? Can you just click, can you see here?
Yes?
You have all these options.
Okay.
Yes, where you can even pull it to a widget. Like if you're downloading data sets for 10 years, then you might need to do it differently and select any of these methods of downloading, maybe pull it in a widget or create a URL where you have all the files there and have somebody helping you to download if it's a big data set.
Okay.
You're interested. All right. Are we together? Like, can we move on?
Yeah.
All right. So we want to now go back. How do we go back? We want to go and select other parameters as well. So can you click on select parameters here? And then go to refine parameters. So now we want to change our variables. And so I go to, when we are subsetting, everything else can remain the same, maybe the months for now. And then now I want to select other different variables.
Sorry, I've got a question. I've downloaded the
Yes.
files, but they all 4 kilobytes, so they're very small. Is that correct?
Yeah, that's okay.
Okay.
Any other question, or we can probably move forward?
Can continue.
Okay. So we have other variables. We can unclick this, please. We also have other variables that we can download here. We'll probably now try terrestrial water storage. We tried it there, and now we have terrestrial water storage in millimeters. Okay, let's say, get my data. Again, you have a list of them as we expected. And so we have for every month another file. So you go and click so that you can download it and save it where you want to save it. And maybe this time you just say this is terrestrial water storage and it's for a certain date, whatever. And then you'll be saving your files like that. So it means that you are able to go back, select your parameters, refine your parameters, and choose a different variable until you are happy that maybe now we want storm surface runoff. For this exercise, what we are going to use tomorrow, we need also storm surface runoff. This one. All right, and then we also need base flow groundwater runoff. We will need this for water budget. So each one of these will download them separately. And then we also need total precipitation rate. Total precipitation rate. So for each one of these, we'll not download them. We have to download them one after the other. This one we have downloaded this. So this is what we need to do and save this so that tomorrow. So we'll go for storm surface runoff, download it separately. After you finish, you download base flow, and after you finish, you download the total precipitation. Now, I also think that you need to know that if you want to download like one of our colleagues here have asked, if you want to download all the data set at once, you cannot do it with GeoTIFF. If you download it with NetCDF, you can just select here on the file format. If you select NetCDF, you can actually select all the variables and it will allow you. So you select all the variables that you were actually at the beginning interested with, and then get the data sets. So with NetCDF, you can select all the variables. Any question up to that point?
Now, okay, let me ask. Hello?
Hello?
Okay, maybe the challenge would be if I don't know which parameter to select for my study or the study I'm doing, like we are doing now water balance.
Yes.
And I'm seeing a lot of parameters, soil, what. How best can I know that this parameter is useful for what I'm doing?
I think that's why we started yesterday with introducing water balance for river basins.
Okay.
Because we are assuming that we first need to have a little bit of understanding on that as hydrologists or water engineers, what actually entails a water balance model and what kind of data inputs you need. Basically, for water balance components, very important is the rainfall, which is now the source of our water to the basin itself. And then how is it, but of the amount that goes to evapotranspiration, we are already estimating here, and the amount that goes into storage, and then the amount that goes as discharge, be it base flow or surface runoff. So those are major water balance components. The moment you have managed to partition your water cycle that way and you have those components, then you are able to speak about water balance.
Oh, okay.
Your basin.
Maybe probably the last one will be the units. For example, I see evaporation is in kilogram per meter squared per second, and then the storm surface runoff is kilogram per meter per second per hour. So will this be also converted later?
Yeah, and okay, I expected that we know those things, but maybe tomorrow when we are doing it, we'll see. But everything, as long as you have the units, you are able to convert. As long as you know that I downloaded evaporation in which units, or if you have any other platform, like we have shown you today, not only GeoDAS, but also other platforms where you might be able to download maybe rainfall, like from image. And very important is to just take a note, what kind of units did I download? Like earlier today when Frank was showing us, we downloaded it in millimeters per month because it was monthly data set. So very important, if you give somebody data set, but they know the units, as hydrologists, they know what to do with it and how to make sure that they're converted and they balance.
Yeah, okay, thank you.
Thank you so much.
Hello.
Hello. Sorry, is somebody online?
Yes, we are still online.
Yeah, somebody was asking, I think, a question, but I couldn't hear. Okay, so I think we have managed to understand our source of data sets, because that's very important. Also, to know where can we get data, especially for scarcely gauged, highly engaged catchments that we have in the Southern African region as well. So we now know where to get data. And so tomorrow we'll see how we are able to process these data sets. Any question?
Hello?
Yes, hello.
Maybe probably like yesterday I was reading somehow. I'm trying to do hydrological modeling on actually South African artesian basin, but there was something that I came across, the uncertainty. Now, how is this, for example, these data sets treated so that they don't have that kind of uncertainty?
Okay, it's a good question because all data sets have that. That's why what we normally do with remote sensing data, we sometimes validate them. And that's why you need to, please, if you are using them for your studies, also it's very important that you get the documentation and the publication that goes with it so that you understand, because it depends on the subject that you're looking at and what you're interested in, the accuracy at which you're looking at things. What exactly did you need? And for me, normally I also, because you understand your basin better. The basins in Tanzania, even just within Tanzania, they respond very differently. So we have other basins where MODIS, let's say ET works very well. And we have other basins where MODIS ET doesn't work very well. Why? Because it's the algorithm that MODIS 16 uses, you know. And so when you actually get to understand and you read the documentation, you get an idea why it works better on a certain area and probably on other basins that respond differently. It doesn't, it's not as accurate. So the best thing is to do a validation. You validate with a little bit of ground data sets so that you check, compared to my ground data sets, how are my satellite derived estimates actually perform.
Okay, thank you very much.
Thank you so much. You can always ask me even offline at any other time.
Yeah, true. I'll get your email.
So thank you so much, Dr. Kujinga, over to you. Looks like I don't have any questions anymore.
Thank you, Doc. Nothing much from my side, but to thank the participants and the UDSM team for this session. Let's meet again tomorrow. Bye-bye.
Thank you so much. Thank you, everybody.
Doctor, I have one addition.
Yes.
I shared a link to a cloud storage where you can find all the data. You can find the Limpopo River Basin, and you can find an optimal version for QGIS, which we'll be using tomorrow. So I request for you all to download the same QGIS version so that we can align better for tomorrow's session, because QGIS vision are varied much. So just download the same version, which is QGIS 3.4.6, so that we can go together for tomorrow's session. Thank you.
Okay, so thank you so much, everybody.